Welcome back. Today we start our series in design Facebook news feed system. Today we will talk about we'll start our first video in the deep dive of the system. In this series, basically what we're doing is that we are solving a system design interview question, which is design Facebook news feed system. And in the previous videos, we talked about the understanding the problems and propose the high-level design based on the scope that we have built in the understanding problem step. We're using this framework to help us to succeed in our system design interview. So today we will talk about the deep dive, and in the deep dive, mainly we will upgrade our own design. So if you look to our design, the feed publishing. Today we'll talk about the feed publishing. We talk about deep dive in the feed publishing. There's things that we can add to improve our design. So, for example, let's just start with the web servers. So the web servers now, they can also let's add to them some things. For example, we will add to them the web servers right now. We will handle the authentication, and also they will handle the limiting. And let's leave the post service right now. Let's leave the notification service. I want to focus on this today specifically in the fan out service. So in the fan out service, I'll just try to tell you what we are going to do, and I will talk in details for everything in it. So first of all, we need to get, before I say what is a fan out service, if you didn't watch the previous video, the fan out is a process of delivering a post to all of your friends. So this is what is a fan out. So the fan out service is a service that is responsible to deliver your post to your friends. So let's upgrade this one. So first of all, the fan out will be connected to a GraphDB, and this GraphDB has the ID of your friends. Let me just pull this a little bit like that, and a text. I will say get friend IDs, and can I make it quite bigger? So yeah. The second thing that we could do also is that let's just let me put this one also here. Okay, so the second thing, after we getting the friends IDs, we get the friends data. So in getting the friends data, let's just can we make this one like that? Yeah, I guess this will be better. And a text, and we'll say that we get friends data, and the friends data, it will be, first of all, we have a cache that stores the recently frequently or recently accessed friends, and let's call it user cache or friend cache, and the user cache will be connected with a DB, user DB. Also, we will add in the newsfeed cache. Let me delete the newsfeed cache. Let me delete it because we'll use a new thing from scratch. So let me just has one like that, and I want to make it. Can I make this like? Yeah. Oh, thank you. Okay. So in this one, First of all, we will have a message queue, and I will tell you why we need a message queue. A message queue. Second, the message queue connect with fan out workers. And lastly, we connect with the newsfeed cache. We store everything with the newsfeed cache. So, before talk on this section, we need to fully understand what's happening on the right section. So, the first upgrade that we did to our design, that we handled the web servers. Beside communication with the clients, web servers enforce authentication and rate limiting. Only users signed in with a valid token are allowed to make posts. The system limits the number of posts a user can make within a certain period to prevent spam and abusive content. The second thing that I want to talk, we did a lot of updates in the fan out service. Actually, most of our updates was in the fan out service. So let's just try to understand what's going on and what is the fan out service and how it works actually under the hood. So the fan out service is a process of delivering the post to all friends. Two types of fan out models are we have something called a fan out on write, also called push model, and fan on read, also called pull model. Both models have pros and cons, and right now I will explain their workflows. The fan out on write, with this approach, newsfeed is pre-computed during write time. A new post is delivered to friends cache immediately after it published. The pros of this fan out on write, the newsfeed is generated in real time and can be pushed on to friends immediately. Fetching news feed is fast because the news feed is pre-computed during write time. The cons: if a user has many friends, fetching the friend list and generating news feed for all of them are slow and time consuming, and it's called hotkey problem. For inactive users, this is a second. For inactive users, those rarely log in, pre-computing newsfeed waste computing resources. We have the other thing that it's fan out on read. The newsfeed is generated during read time. This is an on-demand model. Recent posts are pulled when a user loads her or his homepage. The pros of this approach: for inactive users or those who really log in, fan out on read works better with it will not waste computing resources on them. Data is not pushed to friends, so there is no hotkey at all. The cons: fetching the newsfeed is slow as the newsfeed is not pre-computed. How can we solve that? We adopt a hybrid approach to get benefit of both approaches. We avoid pitfalls in them. Since fetching the news feed fast is crucial, we use a push model for majority of users. For celebrities, for example, or users who have many friends and followers, we let followers pull news content on demand to avoid system overload. Consistent hashing is a useful technique to mitigate the hotkey problem, or to solve the hotkey problem, as it helps to distribute request data more evenly. You can use like round robin or something like that. So let's just take a closer look at the fan out service that you see right now here. So first, we get friends IDs from the graph table, from the graph DB. After that, we get the friends data, and after that, we store everything in the newsfeed cache. So let's put them into steps. The first one is get friends IDs. This is the first. So we fetch friend IDs from the graph database. The graph database are suited for managing friend relationship and friend recommendations. Interest readers wishing to learn more about this concept should refer to the reference material. I will send it to you. Okay. Get friends. The second one is we get friends info from the user cache. The system then filters out friends based on their settings. For example, if you mute someone, their post will not show up on your newsfeed, for example. The third, we send a friends list and a new post ID to the message queue. Fan out for workers fetch data from the message queue and store news data in the newsfeed cache. You can think of the newsfeed cache as a table that has post ID and the user ID. Whenever a new post is made, it will be appended to the newsfeed table, as you can see here in this one. This one is a newsfeed cache table. And the workers store in the newsfeed table, and yeah, that's it. So that's it for today's video. I hope my description was quite good. In the next video, we'll take deep dive in this one, and we will add a lot of components in this one. We'll add a lot in the feed retrieving. So that's it for this video. I hope my descriptions were good. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in future problems.